So you also make a very interesting point in a NASA meeting where as in these are engineers sitting. It's a very important decision being taken, and nobody disagrees, but all of them don't want to do it, right?
Yeah.
And it's a funny situation, and most of the time you see it in meetings, especially when you're dealing with an engineering mindset, an engineering culture. You don't say it openly that you disagree, but you tend to write it off in your mind. And then what happens, the subsequent impact has serious implications, as you write in the book, right?
Mhm.
So how do I overcome that? Because it's not easy, because I may not agree with you, and it's out of sheer respect that I don't want to say anything, and then finally you end up not executing it, which has serious implications. So how do I balance that, Roger, and how did you make that happen at NASA?
Yeah, I think one of the classic case studies is that the Challenger decision, where I have write a case study in the book about it, where one of the engineers he's a young engineer, he's brilliant, he knows that those O-rings won't survive in that type of cold weather, and they should never launch that. They need to wait. They could wait just 5 or 6 hours till the sun comes out and warms the launch pad a little bit. But management is so determined to move forward with this launch, and he tries to express his opinion, but obviously he's not successful. And the management tells him to, take off your engineering hat, put on your management hat. And he goes and ends up going along with the decision to launch. And we all know the tragedy that happened. He's a young engineer. The rest of his life, he lived with that. Every day, he recalled that he was part of the problem, that he was not able to stop that launch. And what could he have done better? How could he have communicated his concerns better? How could he, from a communication standpoint, how could he communicate better? From an ethical standpoint, how could he have said, just listen, here's my badge, I quit, I'm not going to be part of this? And all these things troubled him. He was a great engineer. He knew the numbers. He knew how to do all the analysis that an engineer needs to do. He thought like an engineer, and that was his kind of his downfall in that situation. He lived to regret it. He
So
learned.
how do you recommend he could have handled the situation in hindsight when you look back today?
Well, that's speaking in hindsight is always dangerous, and I talk about that. In the book, that it's the easiest thing in the world. I don't know, and be honest with you, I think that's a terrifying thing for me, is I don't know
Mm,
how I would have done, how I could have done
mm,
better. Um, maybe get more vocal. Maybe just try to be able to express yourself in a way that you know not hold anything back. Say, listen, this is going to cause an explosion if we do this. I know from
mm,
my analysis that these O-rings can't withstand these type of temperatures, and you're taking a risk that is not only endangering 7 lives, 7 astronauts. It's endangering America's course in space and billions of dollars worth of hardware along those lines. It's something that might, you know, touch an engineering manager a little bit better. But I think that's the terrifying thing is that you have to understand, and I think he's a great case study for especially for a young engineer, that you got to do your best to speak up, and you're given an awful lot of responsibility as an engineer, and I think a lot of engineers don't even realize that. But everything engineering does is revolves around safety and the well-being of people, building bridges and things like that, and building rockets and airplanes,
products.
and yeah, all those type of products. It all revolves around safety, and you have a huge responsibility. And if you see something that it isn't safe, or it causes a risk, I think engineers. Another thing is engineers are always always think in terms of risk. And if you can prove along those lines that you're taking a risk to such an extent that if we do have a problem, it's going to be much worse than missing the schedule or paying an extra few dollars to fix a component or taking the time out to, repair a faulty sensor or something like that.
So maybe what you're really saying there is, rather than look at the efficiency and the power of the engineering design, if you focus on the risk, and therefore if you were to really talk about the risk of the wastage of money, the risk of because that's one other way of looking at efficiency, right? It's billions
Absolutely.
of dollars being thrown into the James Webb telescope. So you're really looking at risks from a uh, you know uh, prudence, risk from protecting the company, risk from reputation. So these are
Exactly.
things which are very soft skills, I would say professional skills, which then people respect and then say, hey, he or she is making sense. So when you have that skill, you are able to then move from the rational to the irrational side of the human values. And that's something that if you are able to shift your conversation, your ability to transpose yourself becomes very, very good, right?
Absolutely. And you hit on a perfect concept when it comes to risk, and that's an organization's reputation. And once you have a faulty product that gets out there, your customers, you might take the risk and think, okay, it could be a space shuttle, it could be a TV set, it could be a car. If you set something out there that might not be the best engineering in the world, and it's part of the steering or something, and that steering eventually goes bad after a year, and somebody's spent $20,000-$30,000 on your car, on your product, and they're the steering wears out, you lost a customer for the most part. I mean,
Yeah.
they'll never buy another car from you, and there's kind of a hidden cost in that risk that an engineer has to be aware of, and especially an engineering manager.
In this section, Roger talks about ambiverts. So, if you are an engineer, mostly you are an introvert. There's nothing wrong being an introvert, and getting comfortable with working with extroverts is what engineers need to be ready for. And if you're an introvert, the ability to move a couple of degrees and become an ambivert, where your ability to express when needed, ensuring that you're vocal about your point of view, making that point of view not just in the meeting, but find context even outside the meeting, ensuring that it leaves an impact and therefore helps the organization and the team and the project teams make a decision is important. So if you're an ambivert, express yourself, your ability to switch between these two states is important. That's a skill that engineers need to learn. Also, the fact that in meetings, if you develop the skill of being an ambivert, you at least make a point in the meeting saying, you know what, I believe this is a decision that I will go with. This is the way I think this project can be successful. And that is something that you need to develop and critical for your success in being a leader, and also ensuring that the management succeeds in the goals that they've outlined for the organization.